All right. Hello, everyone. Welcome to ECE 3030. I'm your instructor, Simon Yu. Hope you all are staying safe and had a great summer. So I'm looking forward to working with you on this exciting topic for the fall semester. So this is ECE 3030, Physical Foundations of Computer Engineering. So today we are going to go through the administrative logistics first, and then we will have a brief introduction on the scope of the course. So if you have any questions during the lecture, please feel free to unmute yourself and ask the question directly. Or if you want to use the chat box, then please type in your question in the chat box. I will check the chat window once in a while during the lecture. All right, so here are some details of the administratives, and this is a hybrid touchpoint mode course as we announced earlier in the Canvas. So here this course is for 3 credits, and we are going to meet Tuesday and Thursday afternoon in this time for the live interactions. And then if we are going to meet in person, then the vanilla C340 is the classroom. And all the course materials will be posted in the Canvas system. So all the lectures will be delivered remotely, and the in-person session is just reserved for some review sessions for the exams. And I'm Simon Yu, as I already told you. This is my email, and if you have any questions regarding the course, feel free to send me an email. And also, we will conduct our office hour remotely using the same BlueJean link as we use for the lecture. So the office hour will be Wednesday 11 to 12. If you have conflict of this time, so you can drop me an email and set up an appointment individually at other times. So we do have TA support for this course, but the TA's information is to be determined because we haven't received the final notifications from the department on the TA. But once I receive that, I will post the TA's information on the Canvas, so you will see the TA's office hour as well. And here are something about myself. So my education, I got my PhD degree in electrical engineering from Stanford in 2013. And from 13 to 18, I was an assistant professor at Arizona State University. And in the summer of 2018, I moved from Arizona to Georgia Tech. And now I'm an associate professor at ECE here. So my research interests are as follows. So we are doing the research on the nano-electronic devices. And in particular, we are working on the non-volatile memories. And also my lab is working on the integrated circuit design and electrical design automation. And also we're interested in the applications that are driven by the neuromorphic computing and also the deep learning as well. So this is the website for my lab. If you are interested, you can take a look. So let me check if there's any questions from the chat box. So is this section A or B? Okay, that's a good question. So this is actually session A. So if you look at the registrar's schedule, this 2 p.m. session is for session A, and the 12:30 session is for section B. But we are going to repeat the same course materials in both sessions, so feel free to attend the meetings on one of the sessions. Any other questions before we move on? All right, so let's talk about the logistics for the hybrid mode. As we announced earlier, all the lectures will be delivered in these live sessions using this link. And the lectures will be recorded and uploaded to the YouTube link here. So if you cannot attend in person, during the live sessions, or if you are living in another time zone, then feel free to watch the videos after the class. So actually we had a survey on the time zone where you are located. So please take like 1 minute to finish that survey, because I can have better understanding on where the students are distributed, so we can have the assignments and we can accommodate the students for different time zones as much as possible. Okay, so then for the hybrid mode, here the assignments, like homeworks and exams, will be due on the predefined due date, and you will be asked to upload your homework in a PDF format to the Canvas. So you can take a picture or scan your paper of your homework, so you can upload that to Canvas. And this is just one example app you can use. And also, we will do the same for the exam. And you can print out the exam by yourself and then write down your solutions. And then you scan your paper and then send up and upload to the Canvas. So the exams will have 24 hours availability time window, so you can finish that within 1 day. And then this is to accommodate students in different time zones. So it's very hard for us to protocol the exams digitally. So the exam will be open book and open notes. You can check your example, the lecture slides or the reference reading materials by yourself, but you should obey the academic owner code. That means you are expected to complete the exam on your own without assistance from others. For example, the online discussions through this chat or maybe other forums is defined as cheating. So actually ECE department is watching for this check problem. So they register account and actually periodically watch the discussions on the chat. So ECE has a representative on this, or maybe on other forums. So please obey the owner code and finish your exam on your own. Any questions so far? Okay, then for the in-person meetings, so we will plan 3 in-person sessions through the semester for problem solving or the materials review, especially before the exam. So the attendance is not graded, and it is optional for you to choose to attend the in-person session or not. And we will divide the whole class into 3 subgroups to satisfy the social distancing requirements, because we cannot hold all the class in the classroom. So here, to make it simple, I just divide the class into 3 groups based on the alphabetical order of your last name. So that means if your last name is in the range of A to H, so we are going to meet September 17th, and then I to O, October 22nd, and P to Z, November 19th. So those are the optional in-person sessions you can attend. And if we have the in-person meetings, then we have to follow the guideline from the USG, requiring the mask. And if students do not comply with this requirement, students will be asked to leave the classroom and report it to the office of the dean of the students. Any questions on those logistics? If you have questions, feel free to unmute yourself and ask the question. And also we can utilize this chat box here to answer the questions. If no, then we move on. So the prerequisites for the 30-30. And I assume that all of you have completed 2020 Fundamentals of the Digital System Design, where you have learned the basics of the computer system and the digital design principles. For example, you have learned like the logical gates, like the NAND gate, NOR gate, inverters, and also the organizations of the computer system, where you have the processor and you have the memory, and also the ISA, the instruction set architecture, and some understandings of the assembly language. And also 2040 circuit analysis. So the basic concepts like the DC-AC circuit theory and analysis. For example, the RC circuit. How do you analyze the delay for the RC circuit? So I think those are the prerequisites for this course. And the follow-up courses after you are done with the 30-30. If you want to dig more into the computer hardware design, then here we have two follow-in courses you can select. One is 3150 VLSI and Advanced Digital Design, and one more on the 4000 level is this 4130 Advanced VLI Systems. So after you have taken the 30-30, then you should have the foundations for those follow-up courses. All right, so then you may be more interested in knowing the assignments and the grading. So here we will have homework for 25% of the total grade. And we will have 5 sets of the homework. That means 5% each homework. And midterm 1 will be 20%, and midterm 2 will be 25%, and final exam will be 30%. So final exam will be cumulative. That means final exam will cover the materials of the whole semester. And the final grades will be based on a curve using all the grading components here. So that means after the final exam, we will have the weighted total, and then we look at the distribution and look at the median of the distribution, and then we may set, let's say, a half sigma above the median to be like A, and the median maybe minus half sigma to be B. So we will decide that scale later after we see the distribution of the grades. Any question? If no, then we will move on for some other policies. So the midterm exam tentatively is scheduled to be like September 24 and October 29, and the final exam will be in the final week. And all of those exams will be done remotely. As we announced earlier, you will have 24 hours time window to finish that. And all the homework and assignments are due on the due date. So here are the late submission policy. If you are within 24 hours late, your score will be multiplied by a factor of 80%. If you are between like 24 hours to 40 hours late, your score will be multiplied by 50%. And if you are late more than 48 hours, we will not accept that. So that means your score will be 0 for that particular assignment. And questions regarding the homework and exam grading must be asked within 1 week after the homework or the exam is returned. So if you have questions regarding the homework grading, please contact the TA after the homework grades posted on the Canvas. Similarly, for the exam, you may contact me for the grading, but must be asked within 1 week. And please refer to the syllabus regarding some other generic issues. For example, the academic integrity, accommodations for students with disabilities, absence in the religious observance, and medical emergency, especially in this COVID-19 pandemic period, and also student-faculty expectations agreement. So I have uploaded the syllabus to the Canvas. You can find that under the folder of the files. Any questions so far on those policies? So there's a question. Is the exam for the whole 24 hours, or is there a timer? So this is to be determined later on the exact procedure, because I don't think we need 24 hours to solve all the questions. So the amount of the questions are just for like 2 or 3 hours. But I will find a way to set the timer if we can. But if it's not very straightforward, then I can have all the 24 hours time window for you. This is to be determined later. And one more question. Will the lecture slides be made available in addition to the YouTube videos? Yes, so actually, if you log into the Canvas now, you will see that the lecture slides are already pre-uploaded before the lectures. And this is a pre-lecture. We have the lecture slides ready. And also after the lecture, I will post the marked version of the slides, because sometimes we will derive the equations or we will do some examples in the lecture. So we will have some marks on the slides. I will post that as well after the class. So you have two versions. One is without marks, one is with marks. All right. Any other questions? If no, then let's move on. Textbook. So there's no official textbook required for this course, but we do have some supplementary reading materials. Those reading materials are no need to purchase. So one of that is this book from Professor Chen-Min Hu of UC Berkeley on this modern semiconductor device for integrated circuits. And Professor Hu is very kind to allow the free download of the PDF version of the book from his website. So you are encouraged to download the chapters for free here. So this will be used for the first half of the semester. And the second reading material will be this Cedra and Smith microelectronic circuits. And there are multiple editions of this book. I think the latest edition may be the 7th or even the 8th edition. There are many chapters within this book, but we will only use 3 chapters. So I will upload those 3 chapter PDF to the Canvas for your reference. But the most important resource for this course will be the lecture notes, and especially after we have the marks on the lecture notes, you will have that after the class. And one more reference I want to point out is that for the lecture slides, if you look at the area here, this comment area under the slide, I have already typed in the key message of this slide. So you can also review here for the content of this slide. Any questions? All right. So the course objectives, ECE 3030, as the title suggested, deals with the physical aspects of the computation, and our perspectives is as follows. So the digital information, as you know, represented by the digital ones and digital zeros, are actually carried by the electrons or in the form of the current, for example. And also we are going to learn a new particle, which is called holes in this course. To make it simple, the holes, you can think, is opposite of the electrons. So this is something we're going to learn later in more details. And the information processing actually is done by the electronic switches that allow or block the flow of the electrons or the holes. So this switch is called the transistor. So the transistor will be the building block for all the digital circuits used in your microprocessor today. And the transistor we are going to learn in this course is in the form of the MOSFET, metal oxide semiconductor field effect transistor. So this is one particular type of transistor, and we are going to learn it in more details later. But you should know that transistor is a building block for all the digital circuit. This is a fundamental element in the digital circuit. And then the information is carried to different part of the chip and the outside world through the metal wires. And we call those metal wires as interconnect. So basically, we are going to transmit the signals by electrons, which flow through the wires or interconnect from one part of the chip to another part. So this is the interconnect. And finally, we need to store the information. So you store the digital 0 or 1s as the electrons trapped in some devices. And this is for memory. So you store the information in your memory devices or circuits. We're going to learn that as well. So this is the course objectives. And here we have a brief outline of the topics to be covered. I will quickly go through that. We will learn great details in this fall semester. So here I just want to quickly go through that. So first we will talk about the interconnect, which is the communication between different parts of the chip. And then we will discuss the semiconductor physics, which will talk about how silicon is behaved, because all the transistors today are made of silicon material. So we need to understand silicon first. And the transistor, as we discussed, is a building block. So then we will discuss this MOSFET and this building block for the digital circuit in great details. And after that, we are going to discuss a very simple circuit module, which is this CMOS inverter. And this is made of 2 transistors. So 2 transistors will be 1 inverter. And we will discuss the operations of these inverters in more details. And then we will discuss the scaling of those technologies. So this is a driving force for the semiconductor industry for the past 50, 60 years. So the devices have been scaled from the micrometer scale to today's nanometer scale. So we will discuss the driving force for the scaling. And after that, we will talk about the memory technologies, where you store the information 1 and 0 into those like SRAM, DRAM, flash memories. And finally, we will discuss some advanced topics. And depending on the schedule, we may have some guest lectures on those topics. So here the guest lectures are outside the scope of the exam, so we will not have exam questions on those. This is just for your broader interest. And then this is the tentative schedule for the semester. Of course, this is subject to the change depending on our progress. And we have roughly like 20 lectures and some review sessions. And also here we have the midterm 1, midterm 2, and the final exam after the Thanksgiving. And the 5 homeworks. So any questions on the schedule? And one final remark is on the resources. So here we have the recorded lectures from the last spring semester. So I taught the 3030 in the last spring semester. And I posted all the lecture videos in this YouTube link. But we will have a new link for this semester. But if you want to review the last semester's material, or if, for example, if you want to study early, then you can watch this. And we have all the lectures available there, even before the COVID shutdown. Because from the beginning, in the January, when I taught the 3030, I asked the TA to record the lectures in the classroom through a camera. So we do have all the materials for 3030 available in advance. Any questions? If not, then I will stop recording here.